Welcome to This Explainer. I am stepping in today as your master critic for a completely interactive grade makeover kitchen audit. We are taking on a topic that is absolutely pivotal for your success in Cambridge Mathematics AS and A level, specifically paper 9709. Today, we're mastering probability and statistics too, and we are focusing entirely on hypothesis tests. We're talking null and alternative hypotheses, significance levels, and those notoriously tricky type 1 and type 2 errors. Mastering this isn't just a good idea, guys, it's absolutely essential. Why? Because this topic appears in literally every single examination series. You can't hide from it. So, we're going to conquer it together by putting some failing, messy student responses on the chopping block, dismantling them, and rebuilding them into a 5-star, perfect mark answer. To kick off our audit, I want to show you the sour ingredients we're dealing with. This is a direct quote straight from the grading room, pulled right from the principal examiner report. They explicitly noted that top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. Think about what that actually means for a second. It introduces the core challenge of this exam. Rote memorization is basically just reading a recipe, and that simply isn't enough anymore. You can't just memorize a formula for a normal distribution or a binomial test and expect an A-star. Examiners are actively looking for your ability to take the theoretical concepts of significance levels and apply them to completely unfamiliar, sometimes bizarre, real-world problems. When the ingredients change, you still have to know how to cook.
Which brings us to a vital question. Why do so many capable students completely fail when the context of the question changes? If they know the math, why are they dropping so many marks? Well, let's look at two typical student profiles I see all the time. First, you've got the student who overcomplicates the recipe. Let's call him Alex. Alex throws a bunch of unanalyzed mathematical facts onto the page, hoping something sticks. Then you've got Sam. Sam rushes the writing process, panics under the time limit, and forgets crucial structural steps. Today, we are doing a deep dive to dissect these exact disasters. We're going to figure out why unfamiliarity trips up Alex and Sam, and exactly how we can fix your approach so you never end up serving an undercooked answer.
Here is our roadmap for today's makeover. Number 1, core concepts. Number 2, the procedural framework. Number 3, examiner warnings. And finally, number 4, exam strategy. Let's jump right in. Section 1, core concepts, defining the errors. All right, let's look at the foundational framework. According to the syllabus, the hypothesis testing framework is all about utilizing systematic analysis and evidence-based reasoning to evaluate alternatives. What does this mean for you in the exam room? It means Cambridge is testing your systematic analysis skills just as much as your calculation abilities. It's not just crunching numbers to find a p-value. It's about logically weighing evidence against a null hypothesis and making a reasoned decision. When we look at a failing response from someone like our hypothetical student Alex, we immediately see the disaster: no command word application and zero systematic reasoning. It's just a mess of numbers. You have to evaluate the alternatives systematically. And nowhere is that systematic reasoning more crucial than with type 1 and type 2 errors. Under exam pressure, students mix these up all the time. It is a classic kitchen disaster. To fix this, let's use a visual story method to mentally encode the difference forever. Imagine a fire alarm system. A type 1 error is rejecting a true null hypothesis. In our story, the null hypothesis is that everything is fine. There is no fire. So, a type 1 error is a false alarm. The alarm rings, you reject the null, but there's no fire at all. You took action when you shouldn't have. A type 2 error, on the other hand, is failing to reject a false null hypothesis. So, there is a fire, but the alarm stays completely silent. It's a missed catch. By visualizing the false alarm versus the missed catch, you instantly anchor these highly theoretical errors to a conceptual understanding you can use on any test. Section 2, the procedural framework, the method mark strategy.
Okay, quick pause. If you want to stop serving up average grades and unlock the secret recipe for an A-star, make sure you subscribe to Ace the Exams, at Ace the Exams right now, and hit that notification bell. All right, let's get back to the kitchen and recook this response. In Cambridge exams, you don't just get marks for the final answer. The grading scheme heavily awards method marks purely for your process, so we're going to use a highly standardized 5-step procedural sequence. Step 1, identify key elements. Extract your parameters from the text. Step 2, apply relevant principles. Are you using a normal approximation or sticking to binomial? Step 3, execute analysis with clear working. Step 4, verify results. Step 5, present format. State your final conclusion clearly. If you process data through these 5 steps, you build an absolute safety net of method marks, even if you make a silly calculator error at the end. Now let's talk about step 5, because this is where students like Sam hit a massive roadblock with their sentence connections. The presentation of your information must follow strict conventions: headings, terminology, formats, and annotations. When dealing with null and alternative hypotheses, using the correct terminology like H0 and H1 is absolutely non-negotiable. If your text flow is a mess, I recommend utilizing the classic PEEL structure: point, evidence, explanation, link, to rescue your paragraph. State your point, give your statistical evidence, explain what the test statistic means, and link it right back to the original question. Leaving out the definition of your random variable or your annotations will forfeit major points.
Section 3. Examiner warnings. The top 3 mistakes. Welcome to the interactive taste test part of our workshop. Looking directly at historical principal examiner reports, we can expose the top 3 mistakes that ruin scores. Challenge number 1. I want you to mentally scan the common errors and spot the biggest trap. Number 1. Confusing cause and effect, especially with significance levels. Number 2, forgetting to check format and presentation, like writing a sloppy conclusion that doesn't explicitly state if the null hypothesis is rejected. And number 3, answers not specific to the context given. Did you spot the absolute worst offender? Yep, it's number 3. Examiners constantly see candidates losing easy marks because they write generic textbook conclusions instead of referring to the actual scenario in the prompt. Let's do challenge number 2. Look at this side-by-side comparison. There is one hidden critical error here that forfeits up to 5 marks in an extended response. On the not that side, you see assume definitions, write generic responses, and ignore presentation. The critical error I'm highlighting live for you right now is writing a generic response. If you just write reject H0, there is evidence the mean has changed, 0 context marks for you. Instead, do this. Contextualize the answer. Say, there is sufficient evidence at the 5% significance level to conclude that the mean lifespan of the batteries has decreased. Also, define your terms. Say, let P be the probability of a defective microchip. It takes 5 extra seconds, but it mathematically guarantees you the final presentation marks. Section 4. Exam strategy. Evaluation. To push your grade from a B to an A star, we have to focus on the higher order assessment objectives. This is the ultimate winning argument: the deconstruct, solve, evaluate framework. Top-scoring candidates don't just calculate, they evaluate the whole dish. When interpreting a hypothesis test, you need to identify limitations. For example, did we have to use the central limit theorem because the underlying distribution was actually unknown? You need to question assumptions. Is it truly safe to assume the sample was completely random? By considering alternative perspectives and justifying your statistical decisions with hard evidence, you prove to the examiner that you have that connected, conceptual understanding they are desperately looking for. All right, we are plating our final 5-star presentation. We're going to distill all these examiner insights, methodology steps, and common traps into an actionable checklist for your exam prep. If you remember nothing else from this makeover, remember these 3 golden rules. Rule number 1, always define your terms and hypotheses clearly before you even touch your calculator. Set up H0 and H1 flawlessly. Rule number 2, execute the method mark strategy sequentially. Write down every single logical step so you capture those process marks. Rule number 3, anchor every single concluding answer to the specific context given in the word problem. Talk about the actual variables in the text, whether it's plant heights, wait times, or defective parts. If you follow these 3 rules, your response goes from a messy disaster to an absolute masterpiece. Which leaves us with one final, provocative question. Are you ready to stop merely memorizing formulas and start actually proving your conceptual understanding? The tools and the recipe are now fully in your hands. Your very next step is to grab a Cambridge 9709 past paper and practice applying these exact rules to a hypothesis test question today. Thank you so much for joining me for this explainer. Before you go, make sure you subscribe to AC Exams at AC Exams, turn on those notifications, and jump into the comments to let me know which math subject or level you find the absolute hardest. Keep practicing, and I will see you in the next one.